Not because of technology, not because of fuel, but because reality has a built-in speed limit. So here's the question. If humans can break sound barriers, can we ever break the light barrier? Or is light speed the one rule we can never cheat? Light doesn't just move fast. It moves at 299,792 kilometers per second. That's fast enough to circle Earth 7 times in 1 second. But here's the terrifying part. No matter how advanced your spaceship is, no matter how powerful your engine becomes, physics says you will never reach that speed. Why? Because the closer you get to light speed, the universe starts to fight back. According to Einstein's theory of relativity, as an object moves faster, its mass increases. Faster you go, heavier you become. Approach light speed, your mass approaches infinity. And infinite mass requires infinite energy. Pause and think about that. Where do you get infinite energy in a universe that is finite? You don't. That's why light speed isn't just hard to reach. It's mathematically impossible. So ask yourself, what if we build a perfect engine? What if we invent fuels beyond imagination? What if AI designs ships smarter than any human? Would physics still say no? Because here's the twist. Even if you could survive the energy problem, time itself would begin to break. Seconds would stretch. Clocks would disagree. Reality would desync. And that leads to something far more disturbing. Time dilation. Because in part 2, we'll explore how time travel accidentally appears the moment you chase light speed. And once you understand that, you may realize why the universe never wanted us to go that fast. What if traveling faster doesn't just move you through space, but pulls you out of time itself? What if chasing light speed accidentally turns your spaceship into a time machine? And what if that's exactly why the universe stops us? At everyday speeds, time feels normal. 1 second is 1 second. But when you approach the speed of light, time begins to slow down. This isn't science fiction, this is proven physics. Astronauts age slightly slower than people on Earth. GPS satellites must correct for time distortion, or navigation fails. Now imagine going 99.9% the speed of light. Time would almost stop. Inside the spaceship, your heartbeat feels normal. Your clock ticks normally. But outside, years pass. Decades pass, civilizations rise and fall. You leave Earth on a short trip and return to a future where everyone you knew is gone. Here's the disturbing question physicists struggle with. If moving fast enough lets you outrun time, what happens at the speed of light? Does time freeze completely? Does causality break? Does the universe lose its ability to keep events in order? Because once cause and effect collapse, reality itself becomes unstable. Light speed isn't just a speed limit. It may be a protection system, a boundary that prevents paradoxes, a rule that stops time from unraveling. Maybe the universe isn't limiting us. Maybe it's protecting itself. What if space isn't empty? What if, at extreme speed, space itself turns solid? We imagine space as a silent vacuum. Nothing, empty, safe. But physics tells a different story. Invisible energy popping in and out of existence. At near light speed, you crash into them. As you accelerate, particles in space become weapons. A single hydrogen atom at light speed hits with the force of a high-energy particle accelerator. Now multiply that by trillions. Your ship isn't traveling through emptiness anymore. It's smashing into a cosmic radiation wall. So ask yourself, how do you shield against the universe itself? There's more. According to relativity, space and time are woven together into spacetime. When you push against spacetime too hard, it pushes back. Approach light speed, and spacetime becomes infinitely stiff. Like trying to stretch a rope that refuses to stretch. It may be a structural limit. Not a rule we can break, but a wall we can only approach. If space itself can fight back, what hope does technology have? What if the real limit isn't speed, but information? What if the universe only works because nothing can move faster than light? And what if breaking that rule would shatter reality itself? Everything you experience, sight, sound, touch, thought, is information. Light is how information moves. And physics has a terrifying rule. No information can travel faster than light. Not signals, not cause and effect. Not even reality updates. This rule keeps the universe synchronized. In some frames of reference, That message arrives before it was sent. Read that again. Before cause comes effect. If causality breaks, logic breaks. You could stop an event that already happened. You could receive a warning from a future that never occurs. Physics calls this a paradox. The universe calls it unacceptable. But what about quantum entanglement? Yes, particles influence each other instantly. But here's the catch. You can't control that information. The universe allows weirdness, but never chaos. If faster-than-light travel breaks cause and effect, maybe it's not impossible, maybe it's forbidden. What if the universe isn't stopping us with rules, but with cost? What if light speed is reachable, but the price is so high that no civilization can ever afford it? Every increase in speed demands energy. Double the speed, more than double the energy. Approach light speed, the energy requirement explodes, not linearly. Not exponentially. It goes toward infinity. This isn't an engineering problem. It's a mathematical dead end. To push a small spacecraft to near light speed, you'd need the output of entire stars. Not for years, not for decades. For seconds. Ask yourself, what kind of civilization burns stars just to move one ship? Energy doesn't come without consequences. Extreme energy creates intense radiation, gravitational effects, spacetime distortion. Push hard enough, and your engine becomes a cosmic disaster. You're no longer traveling through space, you're damaging it. Some scientists think this is no accident. Civilizations that try to reach light speed might destroy themselves first. Energy limits could be a cosmic filter, a barrier separating survivors from those who push too far. Is light speed not impossible, but self-destructive? If energy alone can end civilizations, maybe the universe is warning us. What if I told you scientists have already imagined ways to beat light speed? No breaking the rule. No infinite energy. And yet, none of them actually work. Why? You've heard of warp drives. Instead of moving the ship, you move space itself. Compress space in front, expand it behind. The ship doesn't go faster than light, space does. Sounds like a loophole, right? There's a problem. Warp drives require negative energy, exotic matter. Something with mass below zero. We've never found it. And quantum physics suggests it may only exist in microscopic amounts. Not spaceship-sized bubbles, even worse. A warp bubble may trap you. You can't steer it, you can't stop it. You can't send signals outside it. You arrive wherever spacetime throws you. Ask yourself, is that travel or cosmic roulette? Wormholes. They demand impossible conditions to stay open. Every faster-than-light idea turns out to be an illusion, a technicality that reality refuses to honor. So maybe light speed isn't something to defeat. Maybe it's something we are never meant to bypass. What if light speed exists not as a challenge, but as a boundary no intelligence is meant to cross? Every path we've explored hits the same wall. Energy becomes infinite. Time breaks, space resists. Information collapses, causality shatters. Different problems point one limit. Light speed. Ask yourself, what are the odds that every road fails unless the universe wants it that way? Maybe advanced civilizations don't vanish. Maybe they're trapped, confined to their local stars, unable to spread, unable to dominate the cosmos. A built-in safety system, a universe that prevents any intelligence from becoming unstoppable. This could explain something chilling, the Fermi paradox. If faster-than-light travel is impossible, then the galaxy stays quiet. No empires. No invaders. No cosmic overlords, just isolated islands of thoughts staring into the same unreachable stars. A barrier that limits us, or a rule that keeps the universe stable. And if we ever found a way to break it, should we? If this series made you question reality,